Guys, welcome back to TechMe series on robotics. So this is the second video in robotics. So I'm just going to go over some of the basic principles. Okay, so we went over revolute and prismatic joint in the last video and what exactly is that, as well as 2DOF. So obviously people can notice that DOF stands for degree of freedom. So if it has two joints, it would be like a 2DOF, which the other one has. But of course, when designing robots, it's not just the mathematics that I have to check out in terms of like torque and velocity, but also you have to design the motors that turn your revolute joint. So the motors typically applied to the rotational movements of robots are your brushless DC motors as well as your stepper motors. These are the most common motors. Why do you need such precision? Because it's obvious, right? If you're dealing with a motor and its joints over here, if you out with 1 degree, how much are you out with at the end effector at the top here? It's quite a bit. So especially when you need precision, and the way that you would determine exactly where this brushless DC motor is or where the stepper motor is would normally be by an encoder. It would normally be an optical encoder, or it would be a magnetic type encoder. The encoder would tell you exactly which position the motor is in. You would also be able to determine the speed of such a motor, for example, as well with the encoder. What would we use for the linear motion or encoder, or you would use a potentiometer? All right, to determine exactly where it is. So these are all giving you an idea of how to build your robot from a motor perspective, how to design its joints with basically the heaviest payload in mind.